In this video, we're going to talk about how to access elements of a data structure with logical statements. Specifically, we're actually going to focus on accessing elements of a vector, but similar ideas can be used for data frames and lists and matrices, etc. So, subsets of the elements of a vector may be selected by appending the name of the vector, or to the name of the vector, an index vector with square brackets, left and right square bracket. So first, let's create a numeric vector that contains the values 2, 4, 6, all the way up to 16. So if you've watched some of the previous videos, you know that we can do this with the seq function or sequence function. So we want values running from 2 to 16 in increments of 2. So if we do that, that is going to give us the vector 2, 4, 6 all the way up to 16. Okay. Let's say that we wanted to access the second, fourth, and sixth elements of A. So what we could do here is we would have A, so the name of the vector, and then in square brackets, we have the index vector, which contains the elements of the vector A that we want to access. So we're going to give it the values 2, 4, and 6 in the form of a vector. And as expected, if we run this in R, it's going to return the values 4, 8, and 12, which are the second, fourth, and sixth values of A. Sometimes it's easier to access all the elements of a vector except certain elements. So let's say we wanted to access all the elements of A except the second, fourth, and sixth elements. Well, if you want that, then you can actually use the minus sign in front of the index vector. So if we execute the same command as before, but instead we put a minus in front of the C, what it means is that we want to access all the elements of A except the second, fourth, and sixth values. So in that case, we would have 2, skip the second element to get 6, skip the fourth element to get 10, skip the sixth element to get 14, and then also 16, which is exactly what is produced by the R console. We do something similar here where we access all the elements of A except the third through sixth elements. So in that case, it's going to be the first and second elements as well as the seventh and eighth element here. So we get 2, 4, 14, and 16. So you can copy and paste those commands into the R console if you want. You're going to get the same things as before. So that's great if you know specific indices that you want to access. But what if you don't know the specific indices? What if you want to access certain elements of A or some other object based on certain conditions? So whether certain things are true or false. Well, this can actually be determined or performed using logical operators. And the main logical operators in R are the less than symbol, less than or equal to, greater than or equal to, equals, which means are these two things equal to one another. And so I have to point out here that the difference between this and a single equals is that in general, equals assigns a value, a name, whereas this means compare these two things and determine whether they are equal. And also we have exclamation equals, which means not equal to. So your turn. All right, so we want to access, we want to see what happens if we do A greater than 10. What is that going to give us? A less than or equal to 4. So we're actually going to go to RStudio. I've already have all these 4 different commands already out. We want to see exactly what it's going to produce. Okay, so I have my sequence A here, which I need to create. Okay, so just like in the HTML file that we were looking at, we have 2, 4, 6, all the way up to 16. And then now we are going to create this logical statement, A greater than 10. So what is it going to give you? So if you have used other languages before, this is going to give me a logical vector or Boolean vector that is going to give me true for all the values of A that are more than 10, and a false everywhere have a value of A less than 10. Okay, and so if we look at this, the first 5 values of A should be false because none of those values are greater than 10. But the last 3 values, 12, 14, and 16, are greater than 10. And we see here that we do in fact have 5 falses and then 3 trues. So that is what we expected to get. In the second command here, I'm going to execute A less than or equal to 4. The only values of A that are less than or equal to 4 are the first 2 values, and so we expect the first 2 values to be true and the remaining values to be false. And that is exactly what we get. That's exactly what we get here. So A equals 10. This is asking which values of A are exactly equal to the value 10. And we can see that there's only a single value equal to 10. That's the 5th element here. And so 1, 2, 3, 4, 5. So the fifth element is true, and every other value of that logical vector is equal to false. And the opposite statement would be all the values of A not equal to 10. So if we run that, we basically flip everything. So we get true for all elements but the fifth elements, because all the elements except the fifth one are not equal to 10. Okay, so let's go back to the notebook here for a few other additional details. So more complicated logical statements can be made using the AND, or this is the ampersand symbol, and the vertical bar, which means OR symbol. Okay, so ampersand means and the vertical bar means OR. And so what we can do is we can actually put together logical statements, and if you're familiar with the rules of logic, if you're using AND, then both or all values have to equal true in order to get a true. If it's OR, then if any of the values equal true, then you get a true. And so what we're going to do here is we're going to combine a couple of values here, or a couple of statements here. So we want to execute the following commands in R to see what we get. So which values of A are greater than 6, and which values of A are less than or equal to 10. Alternatively, which values of A are less than or equal to 4, or which values of A are greater than or equal to 12. So we're going to go back to RStudio and look at those real quick. So A greater than 6. Okay, so I see is that the 4th, 5th, 6th, 7th, and 8th values are true. A less than or equal to 10 shows me that the 1st, 2nd, 3rd, 4th, and 5th values are true. And if I do AND, it's going to return a true everywhere I have all trues, which is only going to be in the 4th and 5th elements. Otherwise, it's going to return a false, which is exactly what I get here. Next, we look at the OR symbol. So for the OR symbol, we get a true anytime any one of the elements in each vector is true. Otherwise, we get a false. So when we look at A less than or equal to 4, okay, we see true, true, false, 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 false. A greater than or equal to 12, only the last 3 elements are going to be true, the other ones are going to be false. And so what we do is we're making these element-wise comparisons. In any place where we have a true, so in this first position of the vectors, we have a true and a false. If we OR them together because at least one of them is true, we get a true. If both of them are false, then we get a false. But as long as there's at least one true, when we compare these two different vectors and we combine them using an OR operator, then we're going to get a true. And so if I combine these together, what we should get is the 1st, the 2nd, the 6th, 7th, and 8th should all be true. Okay, and that's exactly what we see here. 3rd, 4th, and 5th are going to be equal to false. And so how do we use those logical statements to extract certain parts of a vector or some other object? Well, we can actually pass those logical statements into the square brackets that we talked about earlier. So if we wanted to return only the values of A, where A was less than or equal to 6, we could execute the following command. If we wanted to return the values of A that were equal to 10, we could use the logical statement A equals 10, and then we do that in the square brackets to get the values of A that are only the values of A that are equal to 10. And then lastly, if we combine these logical statements, we're going to return all the values of A that are less than 6 or equal to 10. And so just for fun, even though there's not a your turn here, I'm going to just copy and paste these into R. I'll remove all the stuff that doesn't matter here. So delete that. So if I run this first command here, it's going to return all the values of A that are less than 6, so it's only 2 and 4. This will return all the values of A equal to 10. If you remember, there was only a single value of A that was equal to 10. And then lastly here, we want all the values of A that are less than 6 or equal to 10. So we get 2, 4, and 10. Otherwise, none of the values satisfy this criterion.